there are many factors that can change the output, change the voltage of the load or the grid. So we want to make sure to get the feedback from the output. So that's something I wanted to mention for now. Then let's just like do an example using a half bridge, and I wanted to show you the application of freewheeling diodes. So this is VDC over 2, VDC over 2. This is our load. Here I want to use a thyristor so that you see this as well. Thyristor, a diode, another thyristor, another diode. Let's call this one switch 1, switch 2, diode 1, diode 2. Let's choose this notation for the polarity of the output voltage and current. So this is VO and IO. And when we talked about choppers, you saw these different quadrants that we can have operating in. Quadrant 1, 2, 3, and 4. Excuse me. So here let's just like from this point on, like I'm gonna ignore the delays of the switches. I'm gonna simplify the analysis. So here let's assume that we have just, this is the voltages, this is the voltage across the load. So it's gonna be VDC over 2, and this is gonna be negative VDC over 2. Okay, so we are basically turning on 1 and 2, right? So like here, when 1 is on, the voltage it's gonna be VDC over 2. When 2 is fired, voltage the voltage across the output becomes negative VDC over 2. And you know that like we never fire 2 switches on the same leg at the same time. So when this is on, this is off, and this is on, this is off. Okay. If our load is purely resistive, our current and voltage are gonna be exactly in phase. But let's assume that we have a current that's not in phase with voltage. So like let's assume that we have something like this. Has the same frequency, but it doesn't have the same. I want to make sure that I do it correctly. So let's just like do it like this. And so on. Okay, so sorry, my drawing is not perfect, but I'll try to just show the concept here. And if I continue this, this would be better to do it like this. So here, excuse me, at this point we have fired Q1, right? So once the voltage at this point, like voltage is positive, the current is also positive, right? So we have current going through Q1, right? But as you can see from here, in this interval, like here, both voltage and current, both of them are positive, right? So here, like, we are operating in quadrant 1, right? So here we are in quadrant 1, and Q1 is conducting the current, okay? But at this point, the current starts going negative, right? So the current goes negative. It means that now the load is supplying the current. The current is going to go in the other way, right? And it cannot go back from Q1, right? Because this is a unidirectional device, right? So, but the voltage is still positive, okay? The voltage is still positive. So in this case, what's going to happen is we're going to have the anti-parallel diode. Which diode can conduct the current? If it's going this way, it's going to go from D1, right? So here D1 is going to start taking over, right? And we're going to be operating in which quadrant? Our voltage is still positive, but our current is negative. So voltage is still positive, right? So we're either like 1 or 4, but current is negative. So it means that we are going to be in quadrant 4, okay? Then while current is still negative, we have switching happening here. So Q1 is off, now Q2 is on, right? When Q2 is on, the voltage across the load becomes negative VDC over 2, right? So our voltage becomes negative. Now here we have negative voltage, negative current. So like this is basically the path for the current, right? Our voltage is negative VDC over 2, and our current is negative as well. So here Q2 is basically conducting the current, and we are going to be operating in quadrant 3, where both voltage and current are negative. At this point, current, we have a zero crossing for the current, and then current becomes positive, right? So then our load is basically supplying the current. So like it wants to go this way in the positive direction, right? It can't go through the thyristor anymore, right? So it has to go through D2. Okay, and here we're gonna